Hello again from Skip, Victor Echo 6, Bravo Golf Tango. Around 3 years ago, I was given this old IFR 1200S. It was in pretty rough shape. Knobs were broke off, and some of the control shafts themselves were snapped right off. I've been tripping over this thing for quite a while, so I thought I'm gonna take this thing, put it on the bench, and have a look at it finally. I've had a couple of these now, and I've worked in these before, but I've never had one torn apart quite this in depth. The front panel does come off kind of nice once you figure out what all this to disconnect and then get it laying on the bench, and even from there it's still going to come apart. The actual front panel or controls are on their own separate board, which are piggybacked on the main faceplate of the whole machine itself. So lots of nuts and bolts to take apart to get it assembled so I can get at the actual switches. There were two rotary switches that had the shafts broke off in this picture. One of them's already replaced, and the second one is on the far right hand side, and just about to unsolder it and put in the new one. So I got the front panel put back together, and my first headache was the lock light on the front panel is blinking, and that's indicating you have a unlocked phase lock loop circuit or something like this in the machine. So I had to go looking for that first. That'd be the first one to tackle. It helps to have a full-fledged manual for this thing, which I have. A lot of the modules are hanging in there from the top, not like the circuit boards that are plugged into a motherboard. Anyways, these modules, they all have LEDs, which let you know a status of them. And if, in this case, there's an LED lit up, well, it tells me that's the module that's not locked. This bad module is referred to or called a high loop module, and that's what we're going to discuss next. Before I show you the complete schematic, I thought I'd give you this block diagram, which simplifies it immensely. It's your typical phase lock loop module circuit. The voltage controlled oscillator, which goes from 90 to 1090 megahertz, is amplified and then fed into a prescaler, which divides it by 4. This signal then goes into a programmable divider, which is controlled from a front keypad. So whenever you select a frequency with the front keypad, the output from this programmable divider is always 500 kilohertz. Nothing else, just strictly 500 kilohertz. It's always been divided to come up with that result. Then there's an external reference, 500 kilohertz reference signal from somewhere else that goes into this phase lock loop signal, or circuit, and it develops a tuning voltage, which is fed back to the VCO. That way it's always locked. The VCO voltage is always locked to have an end result of 500 kilohertz. That VCO signal is fed to other parts of the IFR machine itself for different things, but it's essentially how the loop works on this type of phase lock loop circuit. This is the complete schematic of the high loop module, and it's going to be a little too much here to even see, and have it all on the screen at the same time. So I'm going to concentrate in certain areas just to show you what I've done with it. First thing I wanted to do was just see how the voltage controlled oscillator module is working. It's buried underneath the bottom part of this thing. You see in this picture here, it's kind of looks like a box underneath the low pass filter. There's a brass pipe on top of it. Anyways, I disconnected it from the high loop module and put my own DC voltage into it, and then the output of it actually coming out of a low pass filter. I think I have it here. I had it fed over to I was going to hook it to my other IFR spectrum analyzer. I figured I might as well keep it all in the family here, so I rolled this thing over there and plugged it in, and it lit up, and then it just kindly died on me. So this will be part 2 of this presentation. So I had to roll out the big guns to carry on. The big Tektronix spectrum analyzer is a bit of an overkill for what I'm going to be doing here, but hey, when the other one dies on you, what you going to do? It's a little more complicated to run. I prefer the IFR 7550, but oh well, that's the way it goes. This picture, I did make a movie of this, I should have, but then it was when I varied the DC voltage into the VCO, this spike of the signal would move up and down, and I could tune it right from 180 megahertz, I think this is the lower end of it, up to almost 1 gig. I didn't go that far. It took quite a bit of voltage. I didn't know if I was tuning things right or not, so it just confirmed to me that the VCO was working, and it had some decent strength to it. My theory of these kind of circuits to figure out what's going on is it's like a dog chasing his tail. So you got to divide and conquer is what I call it. So I took the circuit, I cut into it, and injected my own signal into the programmable divider. Then I took my fluke voltmeter on the output of the phase lock loop circuit where the tuning voltage would show up, and I'd vary this frequency up and down. And I would get to a point where I must have been getting close to the 500 kilohertz reference because I would see the tuning voltage go up and then go down, go up and go down. So to me, it's telling me that the comparator circuits and the phase lock loop circuit were okay. This is a picture with the module split open and laid out so I can get at the circuitry, and you can see how I've got a test lead going in there injecting the signal. So I thought, well, okay, if the phase lock loop part works and the VCO is okay, it must be this pre-scaler chip. So I ordered one in, but I was wrong. So this is what came next. Okay, this is the old IFR 1200 I'm working on here. You can see the flashing red light indicating there's a lock problem. And I've been working on this thing on and off here for, a couple of weeks anyways. And I thought I had it down to this one part, but alas, it did not help it. This is the area of concern. This is what's called the high loop analog board. Luckily, well, it's not all analog, but essentially takes there's a dual stage voltage controlled oscillator which gets fed into here in this section, and it goes in there, and this one chip on top here, it's U4, it's a pre-scaler, divides it down, divides the signal coming in by 4, and then there's all this digital stuff here, programming from these ribbon cables from the program, and the keypad goes in here and it sets up a bunch of division network. Eventually it all is supposed to come down to 500 kilohertz, I think it is. Yeah, 500 kilohertz across this ribbon cable into this board. And this is a phase lock loop board. That's not the problem. It's up in here. Well, it's looking at around 2.6 megahertz, and it varies depending on what you're doing with it. So this is what I've been fighting with, and it's the pre-scaler I thought was bad. So I replaced it, and it didn't do any good. So I've been playing with this thing here. Now what I've been doing is, you can see these cables. This whole board was a clamshell on top of each other, so I had to split it open, get it laid out so I could work on it. And then of course the coax cables, because they all fed up here, would not fit, so I had all these nice extensions, luckily, to hook things up. These two lines here is what goes, the VCO, voltage control oscillators, underneath this thing, and there's a fast and a slow tune. Right now I'm going into the slow tune. Oh, that's interesting. I thought I was in the fast. Anyways, doesn't matter. And I'm feeding it out here now instead of coming out of here. It's supposed to control, make up a control voltage. Well, it's at 0 because there's no phase lock. So I'm coming out of into it here from a power supply up here. This is what I'm varying with the knob on this dual power supply, just one side of it. I get that fed into there. Now the output of this board, there's an RF stage that comes in here. Here's the signal comes in. There's a whole series of MMIC amplifiers in the splitter. This side here goes into the divide by 4 pre-scaler. This side goes out, which would go to other circuitry, what they call a full duplex module. I've got it coming out of here, and you can see it going down that cable. And I run it over to the spectrum analyzer, and there it is on the spectrum analyzer. Now, I'll zoom in a little bit. We're sitting there about 180 megahertz. So I'm going to vary the voltage going into VCO, and you can see it. I can vary it up and down. It does act erratic. I'm not going to worry about that because I got quite a wiring mess here. It goes really wide sometimes. But anyways, I'm on 180 megahertz. And you can see it's really going bizarre there. It's jumping around. It's probably a slight difference in my voltage. I don't know. Like I say, it's a bit of a wiring mess. Anyway, so I go and we'll shrink this down again. Now I take this scope here, and 180 megahertz going in there. I should be able to find a scope lead here. Where am I? Yeah, I'm on the right one. Yep. I should be able to go in the output of that pre-scaler, which is right here, and I should be seeing some kind of a square wave, divide by 4 from 180 megahertz. And this is what I'm seeing. It's just a horrible looking mess. There's no, I can divide it up. You can see something there, but it's it's almost working there this time. It's weird. Anyways, it's not very good. So I already changed that chip and it didn't do any good. So I took an RF probe now. Now the prescalers are working. I thought there was other issues somewhere else in this board. And I looked at things in this, and that pretty well proved to myself that there's nothing wrong with this part of it. There's nothing wrong with this part of it. So I actually got clued in by Dave. Oh, geez, I don't know why I didn't think of it. Is the signal strong enough going through this darn thing? So I'm going to take this RF probe, and there's 4 little, let's see if I can show you here. These are little MMIC amplifiers. It goes into a splitter here, like I was saying before. So I clamp on the ground here, and I'll go down to the voltmeter, if I can find the voltmeter. There it is. I'm on millivolts, so this is the input to the first amplifier. And you see it's about 2 millivolts. There's the output. 1 millivolt. No gain. There's my problem right there. If I go to the next amplifier, there's that one going into it again, and I go on the output, 7 millivolts. So, gain of 7, or time, from 1 to 7 millivolts. Go to the next stage on the input. There's a 7 again, and I'll go on the output of it, 32. Now I'm going into the splitter, and I go towards the prescaler. Here's the input of that first one, 9.6, and then the output is 47. So these other ones show me that I'm seeing gain. It's that very first one here. We'll go on it again. 2.1 or something going in, 1 going out. So that first one's got to be fried. So I was curious. I think I've got a part to put in there. I haven't tried it yet. If I do, I'll show this to you later. So I thought, I'm going to try something here. Let's zoom this back. Go back over here. I thought, what if I inject a signal? Instead of using the VCO, I take my other IFR over here, this one. It's at 180 megahertz. And I'll plug it in where the internal VCO is. So that's what I'm going to try. And I'll show you what the result was. I was quite amazed. So this is the input from the VCO. So I have to unplug it. My big fingers. Now, I got to find that cable. This is here. This is what's going to the IFR. I've got it 58 going down to the small cable. This is only 180 megahertz, so it's not that lossy. Plug it in here. Now, I go over to the spectrum analyzer again. Again, we're still looking at the output on that splitter, and you can see it. There it is there. Now I can increase my IFR. That's as far as it's going to go right there. But I'll knock it down. Just somewhere that's kind of where the other one was. Now I'll show you what the prescaler is doing. This is the interesting part. Now we're going to go back up to the scope here. If I can find it. There it is. Now watch this when I put the probe on. I'm going to try and do this holding on 2 things at once. It's going to be interesting. Get on a prescaler here. There's nothing. Oh, I got to get on there. Okay, probably because I got the signal so low. Now I'm going to increase my signal. Wrong way. And look at this. I can, I'll have to split this open, divide this, but there's a nice looking signal to look at. So 180 megahertz roughly going in, and the frequency here says 45. That's almost half, or a quarter, which is what the prescaler is going to do. So this is showing me something that first amplifier, which makes sense, is fried, and I don't have enough signal gain going in. I'm really sticking the signal in there strong from the old IFR, the other IFR, to overcome that first preamp that's gone. Now if I leave it at that, go back to here again, I'm going to take the RF probe on those boards again. I'll show you on the voltmeter. Too many probes here. I can't find what I'm doing. So I'll just for giggles here, I'll show you what I'm probing here. So here's the input. Oops, got to be careful here. There, I got quite a bit more going into it. See, 12. So I've gone from what, 1 millivolt to 12 millivolts. So I'm really sticking it in there. Here's the output, 2.9. So it's definitely not amplifying. If I go way past the stage and go over to the input to the prescaler, 200 millivolts. It takes a good strong signal for that prescaler to work. So it shows the Goya. Oh, lost my ground. But remember to use the right tools like an RF probe. Save you a lot of grief. I can't believe I didn't think of using that stupid thing. Dummy me. Anyways, it's been a lot of fun. So now I've got to see if I can. I'll see if I can zoom in here. Show you that RS stage. It's this one right here. That's dead. You can see that's 1, 2, 3, and then there's a splitter. There's one for the one side of the splitter, and there's the other one. Oh, it's behind the post here. You know, there's another one there. It's for the other side of the splitter. So it's this first jobby that's dead. So I'm going to see if I can. I don't have the right one, but I'm going to see. I'm going to put something in it. It'd be better at nothing, because right now it's acting just like an attenuation. Get something in it that works. It'll maybe prove things that maybe I get this thing to work. It might lock up finally and show me that, hey, I got one part of it working. So anyways, that's that part of it. So back again, and I'm happy to say it works. I'll zoom in here a bit. You can see the little red light there in the middle. It's no longer flashing, meaning I have phase lock on that board. So things are looking good. I'll just zoom out here and we'll show you what it looks like now. Anyways, that first Mimic MMIC amplifier, which is what I replaced. Oh, I can't believe. Oh, there it is. I was gonna, maybe I can't see it for that post, but that's it there. It calls for a what's in there is a MSA 0385. Well, I don't have any of those, but I've got mini circuits ER-2, which is kind of the same thing. So I don't know if I can zoom in anymore, if you can see it better, but that's it there. Anyways, I soldered it. The leads are kind of short, but it just barely made it, and it's, like I said, it's working. So far so good. So I'll show you the end result here. Zoom back out. Go back over here again. I'm still monitoring this on the spectrum analyzer, and look how nice and clean it is. So it was definitely all the trying to control over that power supply. It probably had some hum on it. It was making the VCO. This is all working on the internal VCO now. So there it is, and you can see. I think it's. I've got it on CF here. Yeah, 240, 241 megahertz. And this is for the setting of the IFR, I think is at 150 megahertz, if I recall. This is what it comes up with to do all the divisions and stuff. So we'll swing around now. Go back over here. And I'll go back up to the scope. I'm going to show you what it looks like coming out of that prescaler. Does it look sweet? I can tell I'm enjoying myself here. Okay, here we go. Look at that. I think, look at the camera. Yeah, you're seeing it. And it's an area of 60 megahertz. So 60 times 4 is 240 megahertz. So it's definitely dividing it by 4. That was a nice job. I didn't expect to see such a nice sine wave. I thought it'd be more digital. But I guess it's, yeah, it's a little bit. Probably can't see from my fat arm in the way there. Here, I'll do that just in case. There you go. So it's working. Now if I go back with the RF probe, look at the results now. This is the entertaining part here. Oh yeah, I gotta move the camera here a little bit, zoom out maybe. Sorry for all the jostling. That's the one I went to sleep on me, of course. Typical. Now with the RF probe again. Clamp it on here. Okay, so this is cables. This is coming in at the beginning. So we get on the input. Overload. Oh, man. Okay. 0.02 of a volt. That's interesting. I didn't expect an overload. Try that again. Oh, that's better. 4.7. Now, on the output of this amplifier, 70. Remember last time it was like 2 going in, 1 going out. Next stage, I'll just go right to the output. 66 in that area. Go to the next stage, the output. Now she's overloading. Half a volt. Holy crap, I didn't expect that. And then I go through the splitter, and this is the input going into the divide by 4 pre-scaler. 370 or 300 millivolts RF signal, so the pre-scaler needed it. It's a world of difference. I'm having too much fun. Anyways, so that's that part working. I'll have to put it all together now. Get that board crammed. It's, like I say, it's a clamshell. I'll show you when I get it together here what it's doing and what it looks like in there, and see what else this thing doesn't work. It's kind of an ongoing project, this one. So that's it for this part. Okay, back one more time here to show you this whole board thing I was showing you. The end result is supposed to be spitting out a signal of 500 kilohertz, no matter what frequency you set the keypad at. And this is what I'm looking at here. If I get the probe on it, first I'll set my frequency. I'm at 90 megahertz, close enough. I'm just going to step through it in 10 megahertz jumps. Okay, there we go. If you can see it at the bottom there, it's saying 500 kilohertz. I said 500 megahertz, didn't I? Kilohertz, sorry. Now, when I go up and down, I'm at 90, there's 100 megahertz. You can see it change, but it's still 500 kilohertz. So, you know, it's just changing the width between the signals. Where am I at here? It's 380, 300, 400, 500. It gets smaller and smaller, but it's staying at 500 kilohertz, and that's what it's supposed to do. Here's 600, and let's go right to the top here, 900. There's 900 megahertz. So it's still 500 kilohertz, but it's just, you know, like the pulse, almost like pulse with modulation. I guess kind of what it is. Well, not really. I'll go down again. And I'm going down, down, down. There's 400, 300, 200. There's 80. Let's get real low on this thing to see what it does. I hope you can hear me. I'm going to go over to here. Well, there's 78, 75. What's it look like? I'm only looking at? Oh, yeah, it looks like a nice square wave there now. 60, 50. And there's 38. That's low enough. 31. And it starts a little bit of noise on the bottom there. I'm not going to worry about that because it seems the phase lock, the phase lock is still, light is still on. So balance it up. So that's the end result. That's what's coming out of this second board that's hooked to this thing. It's the phase comparator, actually. It's an interesting circuit. This goofy thing. This, like I say, this board here is what takes in the voltage controlled oscillator, which is controlled by an output DC voltage, and set up by the digital keypad entry into this thing. And whatever you set, it comes in here. There's these 3 decade counters, and they set up whatever it's going to be dividing by. And the end result is, no matter what the VCO coming in is it spitting out on one of these lines here on the cable, ribbon cable, 500 kilohertz. So it just divides, and you know, various numbers and all, and keeps it going, and it goes into here. And now there's a 500 reference coming in this line right here. That's another circuit of the machine, but it's fixed at 500 kilohertz. So it's checking the phase between the 500 kilohertz that's developed here and one coming in, and creates a phase lock loop and gives us control voltages here, low and high, or slow and fast. That goes into the dual stage VCO and sets up the frequency. So rather slick device. You learn a lot when you play these stupid things. when it works, that is. A lot of headaches when you can't get it going. Yeah, I want to show you how those 2 boards went together. I've already got them sandwiched together. You see, there's that ribbon cable is in between them, and they just fold up and 2 screws. And then this lid goes on here like this. And there's a series of lock nuts on both sides. I got to put them on yet. And then it all goes. I think there's screws on the side somewhere. There's some, screw there. And then it all just slides into that tin box, and there's screws in the bottom of it. And that module goes inside the IFR. I'll show you that later. Alright, as I promised, here's the completed module. All in the box, screws in the bottom. So, had to disconnect a lot of cables. This thing does slide in here, believe me or not. Oh, look at that, went right in this time, not too bad. This little one here's got to go up. Well, we'll try it. No, not quite. Out she goes again. Oh, we'll try it this way. Anyways, okay. A little snug. And then hook up cables. Different cables plug in here, plug in there. I still don't think this is right. I gotta go to this side. Anyways, you get the idea how it's gonna plug this. So I gotta plug all this together and then fire it up and try it again. So feeling pretty confident. I got that thing fixed. I had it all together, and I was tackling the next problem, which there was no audio at all. I mean, this thing was receiving, but I had no sound coming out of it. And what I found was down on the motherboard for the audio card, there was this set of pins bent over. I think it happened before. So once I straightened them out, I finally got some audio. Okay, so I got it working, and I turned it on, and now that I got some sound, I could test it out better. And I got it on a local FM broadcast station here, and I'm trying to simulate this because this is after the fact, but I found that I'm supposed to go on wide to hear the FM well, and it does do it, but back then it only worked on narrow, not on wide, and the audio was distorted. And I realized that when I switched this with, no knob yet, when I switched this, the darn audio didn't make any difference. So I knew there was an issue there, but instead of wearing out this poor switch with a pair of pliers, it was time to build a set of knobs for this thing so I could switch this properly and not, damage the switch itself. So that was the next step. So a little buffing with the die grinder and put a little slit down it with a black pen and a groove. It turned out not too bad. I was going to paint them black, but I kind of like them silver, so I may just leave them this way for now. But anyways, they fun to build, and everything seemed to work. So with new knobs, I could control the front panel easier. So back to the original problem here of why the audio selection wasn't working between narrow, medium, and wide sound. Unlike the phase lock loop module, these cards are slotted down inside the frame, and there's a motherboard at the bottom which has a set of pins that the board plugs into. How do I work on it? I don't have an extension board or anything like that, so I had to come up with a cunning plan. These header pins on the board and on the motherboard, they're just dual roll pins that you see in all sorts of things, and computers. I don't throw nothing away, and I got tons of these ribbon cables from old computers that go between floppy drives, hard drives to the motherboard on old computers. So this would work. So I took one and I found some pins and put it together, and so I could have a male and female end. And then I started toning it, and then I realized, oh, this ain't gonna work. I gotta reverse each individual pin from side to side, not end for end. So this started becoming a fairly long process. I think there was 40 wires, or 38 or 40 wires. I had to cut and reverse each other, so they'd line up from male to female on each end. And as I did it, I beeped it with the ohmmeter, and then put some heat shrink tubing over it. And one wire at a time, but I finally got it done, and got it plugged into the audio card, down into the motherboard, turned it on, and we were off to the races. So I start following the audio circuit in this thing and how these filters get switched in and out, and it wasn't in the audio card. The next stage was back, I think it was the 10.7 IF module, one of the 10 modules again. Luckily, though, I didn't have to pull them out and open them up. I could just lift these ribbon cables and check the switching functions on the end of the plugs. Well, I couldn't believe it. It went through all these modules, and I wound up going back to what's called the DVM I module. It's a digital voltmeter I/O module, if you can believe it. And again, I needed the extension cable. Now, the big one I had made previously worked, but now there's a second one there, a smaller one. So back to the drawing board and building another cable. And it was at this point that I knew I blew it. I was having so much luck and so much fun with fixing this thing. And these cables, I built them up and toned them, made darn sure, end for end, everything's going to line up. The smaller cable is actually for 5 volts, 12 volts, negative 12 volts, and mostly grounding. So I don't have any pictures, but when I installed these onto the motherboard, I got the little cable over by one set of pins. Didn't even think of it. You can't see down there, so everything's being done by feel. And, well, this is where I blew it. The 12 volts wound up on the 5 volt line, and when I turned the IFR on, everything just went dead, and it made a loud noise, and I heard a pow. Turned it off, I lifted that board out, and sure enough, there's an electrolytic that blew off the board, and I knew right there I screwed the pooch. I didn't think I would be able to fix that board, or very easily anyway, so I went on eBay and started looking, and sure enough, I found one. And actually in Canada, so I ordered it up, and it got to me within a couple of weeks. It was at this point that I went and worked on the 7550 spectrum analyzer that died on me earlier, but I won't get into that right yet. When I got the board and I stuck it in the machine, it fixed all my problems for that audio part anyways. The audio selection for the 3 modes worked like a charm, so I kind of cheated that way, but cost me some money to get that part fixed. But we're not out of the woods yet. Up till now, I've been pretty well just dealing with the machine in receive mode. I did have it transmitting, but this is what I'm seeing now. I'm looking at the modulation meter, watching it bounce off the end. Of course, it's not supposed to do this. You should be steady and set somewhere on the meter wherever I got the modulation knob set. So to figure out this problem, we're back into the receive audio board once again. This is kind of interesting, so I'm going to try and keep this as simple as I can. The audio comes in on the left and goes through various circuits, or switched audio circuits and filters, and it winds up going to that one chip there. It's a MUX switch, a U16. This MUX switch is controlled by 3 lines coming in from the top, and it just selects which audio path is going to come into it, and then it puts it on the output through a series of 3 op amps to the 4th op amp on the far right. The bias of that 4th op amp is controlled by another MUX switch just above it, and the input to them is controlled by 3 more, I'm going to call them switches, and there are adjustments on there for setting FM 0 and different functions anyways, and it's all controlled by those 3 bus lines. From that 4th op amp shown in the green line, the audio path goes up into another MUX switch, which is actually the switch which is controlled by the front panel for different things. And then out of there, again through more op amps, and finally out to the right side and to the meter circuit. So this I'm seeing, this is on that 4th op amp. I'm looking at the audio coming out of it on pin 7 as it gets fed up to that upper circuit, upper MUX switch. And you can see it just, it's on again, off again, on again, off again. You can't really tell what the signal is, but it's bouncing all over. What I found earlier by poking around and looking at different voltages, a lot of these chips have a negative 5 volt reference going into them. And the meter on the right is this -5 voltage. You can see how it fluctuates up and down. Now I'm going to take the left meter, I'm going to put it on the output of that first mux, which is also the input of that op amp, and just, the biasing. And you'll see the relationship between its bias voltage and this crazy fluctuating -5 volts. So that tells me there's something wrong with this 5 volt supply, -5 volt. Well, it's a simple enough circuit. There's a -12 volts coming in on the left to this board, and there's a Zener in there, 5 volt Zener with a 1K current limiting resistor, giving you a -5.1 volt source. So I monitored that, and sure enough, it's bouncing all over. So I replaced it all. I replaced the Zener and the resistor and the capacitor, and it's still there. So this is a scope once again monitoring the output of that op amp, and you can see it's still fluctuating up and down. So the meter on the right is still monitoring that 5 volt source from that Zener circuit, and I've replaced all those parts, so something is pulling that circuit down. So this was the next action I took. You can see the scope here is holding steady the signal, but it's really noisy. And you'll see on the meter there, it's solid 5.1 volts. What I did, I disconnected the Zener, and I brought a wire out, and I've connected it to the power supply on my bench here, and I'm feeding 5 volts to it, which is regulated at 2 amps, so it's not going to pull it down. The control voltage, bias voltage, whatever it's called, going to that 4th op amp is still fluctuating. It's like crazy. So this is what I did next. I took some cold spray, and I give that mux controlled switch chip there, I gave it a shot, and look what it did. So as far as I can figure, that mux switch it was pulling a 5 volt line down, and now that I'm putting a heavier 5 volt supply into it, it's just it's just acting up. So there's the problem. I tried heating it up just with my fingers to see if it would act up, and then that didn't do anything. So I put my soldering gun just slightly above it. Didn't touch it, chip. Maybe I should have, but it didn't want to quit now. But anyways, it told me something. So I ordered some parts from DigiKey, extra parts, spare ones here and there, and I had to wait a few extra more days because FedEx, they can screw things up. All right, then I got the parts from DigiKey finally. So we're gonna pull this chip out, this multiplex chip thingy here. I think is bad in this unit. U17. Make sure you get the right one. U17. Yep, right there. All right. So far so good. This is my cleaner. There it is. I know I have it somewhere. Just gonna clean the tip here, make sure she's not plugging up. All right. It's an old vacuum solder sucker, but it works. that's it. Have a quick look. Yeah, well, we'll see, she's loose. Luckily it's on the edge here. I can, there she goes. Easy peasy. Nice holes. Nicely done. So I got that mux chip replaced, and that fixed the needle from bouncing off the end like crazy, but there's still an issue with the meter. There, it just acted up. Showing the output of the scope up there, nothing. The output is nothing. And it's showing 3 kilohertz. Yet if I do this, you notice it doesn't affect it. You can hear the tone going up and down. The needle and the display does not quit. But if I go over here, it's showing. Oh shit! It's still. I vary the amplitude. Oh, you can't see the darn miserable light. Let's chip this a little bit. There we go. On the gauge on the right, it still affects it. So it is. The deviation part still works. But over here, nothing. I turn it right off. The needle stays there. Stays at 3 kilohertz down here. Well, I looked into it and I couldn't believe it. It was another mux switch, exactly the same part as the one before, below it here. And what it does is select different voltages for driving the meter also. The one from the top there is the battery voltage, so it gives you the meter to read battery voltage, so on, and other things like that. And what was going on is that switch is controlled by the front knob now for meter functions, and sometimes it wouldn't switch, so it was taking a voltage from another part of the circuitry and putting it across to the output, which was the wrong bias for the audio when you're using it as an S meter or as a deviation meter. So I replaced that chip and away it went. And yeah, the meter switch function worked so much smoother too. Before I'd go between functions and that needle was just bouncing all over the place. Now it's nice and smooth. So go figure. So I think I finally got it. You notice the modulation switch here, the scale switch here. This is your percentage of deviation. Well, if I go to 2, of course, it'll pin because it's gone way over. But I can cut it back. Before it would just be stuck. I couldn't do nothing with it. So we'll set it up there high. Now when I go to 6, before it would go bang, stay there, and if I'm lucky, it'd come back. But now they're all switching nice. There's no bouncing off the end. Every scale would bang off the end, and it was that second mux. So it looks like it's working. It's not bouncing all over the place, and the display down below, I don't think you can see it. See if I can zoom in here a bit. You can see I'm not really, kind of low in it. Maybe if I crank this up here a bit. There we go. Now you can see it. So now I got a nice adjustment. Whereas before, when I would go, that's on the 6 scale, 6 kilohertz. I go to 20 scale. Now it's 10. It's 10 up there. Before it would be bang, it'd be gone. I couldn't do nothing with it. There's 30, but see now I got a nice adjustment for it. Most of the time it's on the 6 scale. As soon as I do that, it would bang off the end. So now it's doing its thing. Do I have it? I sure hope so. More and more testing. Well, I think I've got it working. It's been running on and off for a couple of days now, and no issues. This is 98.9, a local radio station. Working good there. I'll go over to the generator. And let's go executive R. Let's go up to, I'll go 442 band. Narrow band here, and we're on battery test. There we go. Modulation's working good. That can slip between here. It doesn't go nuts on me. There's 2 going on here, yeah. So I think we're laughing so far anyways. See modulation on the scope, yeah. I got all the cards stuck back in on top here, things. All I got left now to do is calibrate it. Get this off there again. And check it out a little more here and there, but I think it needs calibration. I know things are a little off. Things are set right, doesn't look quite on, but it's been a struggle. It's kind of fun though. Learned a lot about these stupid things. Don't mind working on, as long as it's not in the digital part of things. I hate that part, but give me something analog any day, I can handle it. Anyways, lots of fun. So, one IFR fixed. On to the next one. This is the 7550 spectrum analyzer. It died of me trying to fix the first one. So it was pretty straightforward, as usual, is the power supply in the spectrum analyzer. Once I got the back part of it off and got the power supply pulled out, first thing I did was start checking diodes, and sure enough, there was a rather high current but fast switching rectifier diode that was open. Once I got that replaced, things started to work. I was looking at the output of this switching supply with a scope, and it kind of drove me nuts. I wasn't expecting this kind of waveform, but it had to be hooked up to the rest of the machine, and then there was some kind of load. It started to give out a proper waveform. So it was much easier to fix than the 1200, that's for sure. Got it back together, and it's back in its rightful spot on the roll-around scope tray, ready for the next challenge. So that took care of IFR number 2. IFR number 3 is this signal generator, IFR 2025. But I've decided not to put it in this video. I'm going to upload that as a separate one because this is getting too long, so stay tuned. Well, that was something different. I didn't think I'd ever upload something like this on here, but why not? I find it interesting, so maybe some of you will also. So again, thanks for stopping and having a look. We'll say 73s now from Skip, Victor Echo 6, Bravo, Golf, Tango.